Hello everyone, welcome once again. Now here we are going to use going to drill multiple holes. So for that we will use PecK drilling. So what is PecK drilling? You will see in PecK drilling. See, in conventional way, what you can do uh, in conventional way, we drill hole in a single way step. Okay, but as if the hole is very deep, then you will see the very rapid wear of the tool. So as you know, the cost of the tool is very high. So instead of drilling the hole in one step, okay, we drill hole in multiple step. What we do here in multiple drilling hole in multiple step, we will drill at a certain depth, then we will take out. So it is called chip breaking process. So in that way we are reducing the tool wear. Okay, so here this one is called one PecK, this another PecK, this one is called another PecK. Here we are drilling hole in the three step. Okay, so in each PecK you see 10 mm increase, 10, 20 and 30. So that is uh, PecK drilling. So how to use PecK drilling? So for that we have G73 code. Okay, so syntax should be like this. First it is at tool position. Okay, in this plane, in one plane tool is at this position. So you will bring the tool at this plane, R plane. Okay, so in that R plane or retract plane, it is also called retract plane. What will you do? You will start drilling from R plane. Okay, so in first PecK you will drill Q length, then you will take out, then you will again drill this much, then you again take out, then you again drill this much. Okay, so you are drilling in PecK. Okay, 3 PecK. So as you know, what is the objective? To reduce the tool wear and increase the chip breaking, so that you can get the required size of the, because if there is chip in the workpiece, so you will get the hole in large hole instead of desired hole. Okay, so G73 cycle will be used. Again, to cancel G73 cycle we will use either G98 code or G99 code. When we use G98 code, we will come to the one plane. Okay, when we will use G99 code, we will come to the R plane. Okay, so G98, see the difference, G98, G99. Okay, initial level return is the end of the cycle, end of a canned cycle, so it will return at the initial level. And but here when we are using G99, R level return. Okay, or retract plane return. So syntax should be like G81, G99, Z-7 are to milling and turning machines only. It is only for milling and turning. Okay, so again here we are. So as I have shown you in previous video, how to add the head CNC header. You can add here. Again you see units millimeter, job number 2, operation drilling, material size 200 by 200 by 20, and then add registered part 11, that is having the size 200 220, and canned cycle and drilling example. Okay, and we are using ET tool number 17. Okay, we are using only one tool, and we will also use some 12 cycle. It means to stop the spindle for a particular second. So P, it is written G04P. This one is millisecond. Okay, so I have written here 5000 millisecond. So it will stop for 5 seconds. P. Okay, so again M98 code I will use to call the subprogram, and then if I writing P1, then I have to write O1. Okay, 1 should be matched. If you want to call any program, if I write P2, then I have to give O2 value here. Okay, O2. So G81 Canned Cycle is activated. And G91 incremental coordinate, we will see. Let me execute one step by step. Okay, see, part is loaded. Next, ET tool number 17, see the tool number 17. It is drill tool, tools, ET tool number 17. Okay, drill diameter 10, tip angle 120, tool length 50. Okay, and if you want to see the register part, mill workpiece, so mill workpiece is 200 by 200 by 20. So this is the registered part. Okay, so next, now let me check if I have done any some offset. So it is only for the drilling, so I will not offset the workpiece. So you will see the workpiece positioned at directly here, machine coordinate value, machine 0 position, like previous video series. I have not set any offset value of the workpiece, so it is directly positioned at the machine 0 position. Okay, so next step, G92 X0. I did not need to write G92, but it is okay. So first tool will come, it will. Okay, what I am doing here by writing G92, I am only changing the origin from here to top corner. Okay, see this, here to here I am going to change programming origin. Now you see across here, before it was not there. Next, tool is set at what height? See, Z2. This command has been executed. So when we are ready, we will bring the tool, because tool is already set. We will turn on the tool, we will give the feed, we will turn on the spindle, M03 clockwise of the spindle rotation, M08 coolant on, G0, X0, Y0 tool position. Okay, and Z at the height of 2. Okay, so this is height of the 2 mm from the top. Okay, next, G73. I am going to use PecK drilling cycle. So for that, how much depth should be there? That value is 15. The track value is from top surface to Q is PecK depth. In how much? From R to it will come. See this Q value. This one is after drilling, how much it will come from R to this one. This is called Q value. So I will write 10 P100 is what is P100? P is total depth. Parameter P is used to for the dwell. Yep, for each. Okay, so P is for dwell. It means after drilling, how much time it will stop. It will wait. So it is millisecond, in millisecond. Okay, so G73, then I am going to use incremental coordinate. Till now I have not used any incremental coordinate. So in incremental coordinate, only how much value I am want to increase, I will give only that value. I don't need to write absolute coordinate system, because here once I write G91 incremental coordinate value coordinate system, that means I have to write, to take to one from one position to here, I have to write only increase in the x coordinate and y coordinate value. If there is no change, then I don't need to write that change. Okay, so drill hole, then it will go to x20, because I am using G90, so it will move only x20. Okay, then again x20, X20, X20. Now after this, tool will move after this one. Tool will move at X60. So from here to here it will trip. Then again, because G91 is unimodal code, it is already activated. So X minus 20, I will take the tool from this direction to this direction. It is not absolute coordinate system. Absolute coordinate system is different. Here I am using incremental. So X plus, once you write G91, then you have to give only in positive or negative direction. When I am going to X minus 20, it will move negative direction from this position. So X minus 20, then minus 20, minus 20. Okay, then G98 PecK drilling cycle over. As you see, it will come at the initial position, then G04. Okay, G04 dwell, and for 5 milliseconds, then G0, G90 absolute coordinate system. I will position here. Okay, so again, now what I am going to use here, I am going to call subprogram to drill hole here, here, and here also. Okay, so I will going to use uh, call subprogram. So to write a subprogram, call a subprogram. M98 code will be used P1 L1. Then M05, that is spindle stop. M30, this one is machine stop, reset all the value. Since P1, then I have to write subprogram here. So G81 O1 subprogram number 1, and G81 Canned Cycle start, Z50 the depth of the hole, retract value from the top surface, then incremental coordinate I will use. You will see here increase in X, then increase in Y, then decrease in X, then increase in X and Y, then decrease in X, then cancel Canned cycle. It will come here directly M05. Okay, then M30. Okay, so I am running the program once more without explaining, so you can take a clear look. Since G04 is there, that's why it is waiting 5 seconds, and P5005 millisecond. Okay, so this is the way you have to program it. Okay, one more time. This is dwell, that's why it is waiting. Well, we give it by G04 and P value. Okay, thank you. I hope you have got the understanding how to call subprogram and how to use PecK drilling cycle. Thank you very much. We will see in next video. So next video I will do some program coding on turning operations. Thank you.